ANOVA, Parametric Test. This is the topic of Biostatistics and Research Methodology and Applied Mathematics, Biostatistics. Content of this topic includes Parametric Test, ANOVA, One-Way ANOVA, LSD Test, Two-Way ANOVA, One-Way versus Two-Way ANOVA. Parametric Test. Definition: Parametric test is a test whose model specifies certain conditions about the parameters of the population from which the sample is drawn. Parametric test is used to evaluate hypotheses. Parametric tests assume a normal distribution of values. Types of parametric test: p-test, z-test, f-test, and analysis of variance, also called as ANOVA. ANOVA, full form is analysis of variance. Definition: ANOVA is a statistical technique specially designed to test whether the means of more than two quantitative populations are equal. ANOVA test is based on the test statistics F, or variance ratio. Assumptions: the observations are independent. Parent populations from which observations are taken show normal distribution. Various treatment and environmental effects are additive in nature. T-test versus ANOVA. Z-test and T-test test the significance of the difference between one or two sample means. ANOVA tests the significance of the difference between more than two sample means. T-test is a special case of ANOVA in which only two means are compared. ANOVA is a generalization of the t-test to three or more groups. In t-test, when you reject the null hypothesis of equality of means, the alternative tells you which one of the two means is greater. With ANOVA, the corresponding test is an f-test, tells you that the means are different, but not necessarily which one is larger than the others. One-way ANOVA. Synonym is completely randomized design or single-factor ANOVA. The one-way ANOVA is an extension of the two independent groups t-test when an experiment contains more than two treatments. One-way ANOVA is a hypothesis test in which only one categorical variable or single factor is considered. Null hypothesis is the equality in all population means if 0 is mu1, is equal to mu2, is equal to mu3, and so on. Alternative hypothesis is the difference in at least one mean. Exercise: 15 tablets are tested for the comparison of 3 assay methods, 5 tablets for each assay. Results of assays comparing 3 analytical methods, method A, B, and method C, are given in this table, with 5 observations. The objective of this experiment is to compare the average results of the 3 methods. Statement of hypothesis: null hypothesis is mu1 is equal to mu2 is equal to mu3, and alternative hypothesis is mu(x) is not equal to mu(y). Where mu1 is average assay of tablets using method A, mu2 is average assay of tablets, using method B. Mu3 is average assay of tablets, using method C. Mu x and mu y is 4 any two means. Null hypothesis is there is no significant difference in averages of assay results of all methods. Alternative hypothesis is at least two averages of assay results of methods are different. We can also say as not all averages of assay methods are equal. Statistical calculations. Let's use symbols for methods as YA, YB, and YC for calculation. These are some equations as steps to calculate in ANOVA. We need to identify sigma y, also denoted as G. It is the grand total of all observations. So, to calculate G, we need to extend the table as to compute totals. In second equation, we need value of sigma y square. For this, we need to add more columns to calculate y square and sigma of y square. Let's first calculate the sum of all observations, sigma ya, sigma yb, and sigma yc. Then the grand total, that is sigma of y. The grand total obtained is 1511. Now perform stepwise calculation of sigma y square. Sigma y square obtained is 152,247. Calculation steps of ANOVA. Step 1 is compute G grand total of all observations. Found is 1511. Step 2. Compute correction term, CT. That is also called as correction factor, CF. CT is equal to grand total square upon total number of observation. So, it is square of 1511 divided by 15. Value of CT found is 152,208.0667. Step 3. Compute raw sum of square. It is sum of the square of all observations. This we have already calculated in previous slide number 9. The sum of square is 152,247. Step 4. Compute total sum of square, TSS. TSS is equal to sigma of y square, which is grand total, minus CT. TSS calculated is 38.9333. Step 5. Compute between sum of square, BSS. BSS has following equation. This equation contains T, I. So for this exercise, this equation is, as with TA square, TB square, and TC square. The values of these as TA square is equal to sigma y, A, whole square. TB square is equal to sigma y, B, whole square. TC square is equal to sigma y, C, whole square. Now calculate between sum of square. BSS obtained is 13.7333. Step 6. Compute within sum of square, WSS. WSS is equal to TSS minus BSS. So, WSS obtained is 25.2. Step 7. Compute degree of freedom. Here, 3 different degree of freedom is calculated. Total degree of freedom, between method degree of freedom, and within method degree of freedom, where n is total number of observations, k is number of columns. Total degree of freedom is 14. Between method degree of freedom is 2. And within method degree of freedom is 12. Step 8. Compute between classes mean sum of square. MBSS. MBSS is equal to BSS divided by between method degree of freedom MBSS obtained is 6.8667. Step 9. Compute within classes mean sum of square. MWSS. MWSS is equal to WSS divided by within method degree of freedom. MWSS obtained is 2.1. Step 10. Compute F value, variance ratio. F is equal to MBSS upon MWSS. So, F value found is 3.2698. ANOVA table that contains all calculated values, as shown here. Step 11. Find critical value of F using a table of the F distribution. Tabulated F value obtained by searching F table with 5% alpha level, with 2 between method degree of freedom in the numerator and 12 within method degree of freedom in the denominator. Let us see the F distribution table with 5% alpha level. Headings of the columns are degree of freedom in nominator, and headings of the rows are degree of freedom in the denominator. For this exercise, between method degree of freedom is 2, and within method degree of freedom is 12. So, select 2 in the numerator and 12 in the denominator. Thus, tabulated F value found is 3.885. Result: calculated F is 3.2698, and tabulated F is 3.885. Here, calculated F is less than tabulated F value. Hence, there is no significant difference. Thus, accept null hypothesis. Conclusion: all means of assays are equal. There is no difference in all 3 assay methods. Second exercise. It is suspected that, for analysts in a laboratory are not performing accurately, a known sample is given to each analyst, and replicate assays performed by each with the following results. Perform an ANOVA. Significant level is 5% level. The observation table contains values of 3 observations of each analyst. Statement of hypothesis. Null hypothesis is μ1 is equal to μ2 is equal to μ3 is equal to μ4, and alternative hypothesis is μx is not equal to μy, where μ1 to μ4 are average assay of sample by respective analyst, μx and μi is for any two means. Null hypothesis is there is no significant difference in averages of all four analyst assays. Alternative hypothesis is at least two averages of analyst assays are different. Statistical calculations. Let's use symbols for methods as y1, y2, y3, and y4 for calculation. Now, we need to extend these tables for calculation of the grand total of all observations and sigma of y square. Let's first calculate the sum of all observations, sigma y1, sigma y2, sigma y3, and sigma y4, then the grand total of all observations, that is G. We have seen in previous exercise that sigma y is represented as T, as shown here in table. Thus, sum of observation of each group is T1, T2, T3, and T4. The grand total obtained is 112. Now perform stepwise calculation of sigma y square. Sigma y square obtained is 1058. Calculation steps of ANOVA. Grand total of all observations found is 112. Step 2. Compute correction term, CT. That is also called as correction factor, CF. Value of CT found is 1045.3333. Step 3. Compute raw sum of square. It is sum of the square of all observations. This we have already calculated in previous slide number 18. The sum of square is 1058. Step 4. Compute total sum of square, TSS. TSS calculated is 12.6667. Step 5. Compute between sum of square, BSS. BSS obtained is 8.6667. Step 6. Compute within sum of square, WSS. WSS obtained is 4. Step 7. Compute degree of freedom. Total degree of freedom is 11. Between method degree of freedom is 3. And within method degree of freedom is 8. Compute between classes mean sum of square. MBSS obtained is 2.8889. Compute within classes mean sum of square. MWSS obtained is 0.5. Step 10. Compute F value, variance ratio. F value found is 5.7778. ANOVA table that contains all calculated values, as shown here. Step 11. Find critical value of f using a table of the f distribution with 5% alpha level, with 3 between method degree of freedom in the numerator and 8 within method degree of freedom in the denominator. Let us see the f distribution table with 5% alpha level. For this exercise, between method degree of freedom is 3, and within method degree of freedom is 8. So, select 3 in the numerator and 8 in the denominator. Thus, tabulated f value found is 4.066. Result: calculated f is 5.7778, and tabulated f is 4.066. Here, calculated f is greater than tabulated f value. Hence, there is significant difference. Thus, reject null hypothesis and accept alternative hypothesis. Conclusion: at least 2 analysts assay are different. LSD test. The full form is least significant difference. It is also recognized as critical difference, CD. When ANOVA results in rejection of the null hypothesis, ANOVA gives significant result as at least one of the groups tested differs from the other groups. However, you can't tell from the ANOVA test which group differs. In order to find out exactly which groups are different from each other, we must conduct a post hoc test. One commonly used post hoc test is Fisher's least significant difference test. This test is a simple t-test, comparing all possible pairs of treatment means. The LSD calculates the smallest significant between two means, as if a test had been run on those two means. Any difference larger than the LSD is considered a significant result. LSD is equal to t multiplied by under root of s square into 1 by n1 plus 1 by n2, where t is equal to the tabulated value of t at the alpha level with degree of freedom from the WMSS of the ANOVA table. S square is equal to the within mean square variance, that is, WMSS n1, and n2 is equals to size of observation in particular groups. If the sample sizes are equal in each group, means n1 is equal to n2 is equal to n, the LSD equation is compressed as given below. Exercise. Find LSD of previous exercise. Significant level is 5% level. Here is the equation of LSD test, where S square is WMSS and T is tabulated T value, because all groups have same number of observations, and 1 is equal to, and 2 is equal to 3. WMSS is already calculated in previous exercise, so just see ANOVA table. The value of WMSS is 0.5. Now see degree of freedom of WMSS in ANOVA table. The value is 8. Now, identify tabulated T value with 5% alpha level and 8 degree of freedom. Let us see T distribution table. Here, it is two-sided test with alpha level 5% and the degree of freedom is 8. Thus, the tabulated t obtained from t distribution table is 2.306004. Now calculate LSD. Put all the values in the equation of LSD. LSD obtained is 1.3315. After the calculation of LSD, now, to calculate the mean differences between groups, let us first find out mean of each group. Now, find difference between all possible groups pair. After calculating the mean difference in all possible groups pair, mark the mean difference greater than LSD. LSD is the least value of significant difference. That means, if the mean difference between groups is greater than LSD, these groups show significance difference. Conclusion: Analyst 1 differs from 3 and 4. Analyst 2 differs from 3 and 4. Two-way ANOVA. Synonym: randomized blocks design, or two-factor ANOVA. The two-way ANOVA is an extension of the paired t-test to more than 2 treatments. Two-way ANOVA is a hypothesis test in which 2 categorical variable, or 2 factors, are considered. A two-way ANOVA tests the effect of 2 independent variables on a dependent variable. Exercise: 8 laboratories were requested to participate in an experiment whose objective was to compare the dissolution rates of 2 generic products and a standard drug product. The purpose of the experiment was to determine if the products had different rates of dissolution and to estimate the laboratory variability and or test for significant differences among laboratories. Tabulated F values are given here. Tablet dissolution after 30 minutes for 3 products with 8 observations of each product is given in this table. Statement of hypothesis. Let first generate hypothesis for tablet products. That is, for column. Null hypothesis is mu A is equal to mu B is equal to mu S, and alternative hypothesis is mu X is not equal to mu Y, where mu A is average of dissolution by product A, mu B is average of dissolution by product B, mu S is average of dissolution by standard drug product, mu X and mu I is for any 2 means. Null hypothesis is there is no significant difference in averages of dissolution of all 3 tablet products. Alternative hypothesis is at least 2 averages of dissolution of tablet products show different. Statement of hypothesis. Now generate hypothesis for laboratories, that is for rows. Null hypothesis is mu1 is equal to mu2 is equal to mu3 and so on, till mu8. Alternative hypothesis is mu x is not equal to mu y, where mu1 to mu8 are average of dissolution of products from particular laboratories. Mu x and mu y is 4, any two means. Null hypothesis is there is no significant difference in averages of dissolution result in all laboratories. Alternative hypothesis is at least 2 laboratories, dissolution results are different. For the statistical calculations, in two-way ANOVA compared to one-way ANOVA, there is additional calculation of row sum. First, calculate sum of all columns, and finally calculate G value. G obtained is 1946. Now calculate row sum. After calculation of row sum, calculate sigma of y square. Sigma y square is 158786. Grand total of all observations, G, calculated is 1946. Now, compute correction term. The value of CT found is 157,788.1667. The value of raw sum of square is already calculated. That is, sigma y square is 158786. Next step is compute total sum of square. TSS calculated is 0.997.8333. Now compute column sum of squares. CSS calculated is 200.333. Now, calculate row sum of squares. RSS. RSS has following equation. This equation contains Ri, that is square of row sum, while C is total number of column with respect to a particular row. Now calculate RSS. RSS calculated is 391.833. Next step is to calculate residual sum of squares, ESS. It is also called as sum of squares due to error. Residual sum of squares found is 405.6667. Next, compute degree of freedom. Here is to compute for different degree of freedom. N is total number of observations. C is total number of columns. And R is total number of rows. Total degree of freedom is 23. Column degree of freedom is 2. Row degree of freedom is 7, while residual degree of freedom is 14. Now, compute mean sum of square of row, MSSA. Answer is 55.9762. Next is to compute mean sum of square of column. MSSB. MSSB found is 100.1667. Compute mean sum of square due to error. MSSE. MSSE found is 8.9762. Now, compute F-value. F-value for rho. That is, FA is equal to MSSA upon MSSE. FA 1.9318. Now, compute F-value for column. That is, FB is equal to MSSB upon MSSE. FB is 3.4569. ANOVA table that contains all calculated values, as shown here. Now, find critical value of FA using a table of the F distribution with 5% alpha level, with 7 rho degree of freedom in the numerator and 14 residual degree of freedom in the denominator. Let us see the F distribution table with 5% alpha level. For this exercise, rho degree of freedom is 7 and residual degree of freedom is 14. So, select 7 in the numerator and 14 in the denominator. Thus, tabulated F-value found is 2.764. Result: calculated FA is 1.93 and tabulated FA is 2.764. Here, calculated value is less than tabulated value. Hence, there is no significant difference. Thus, accept null hypothesis. Conclusion: there is no significant difference in averages of dissolution result in all laboratories. Now, find critical value of FB using a table of the F distribution with 5% alpha level, with 2 column degree of freedom in the numerator and 14 residual degree of freedom in the denominator. Let us see the F distribution table with 5% alpha level. For this exercise, column degree of freedom is 2 and residual degree of freedom is 14. So, select 2 in the numerator and 14 in the denominator. Thus, tabulated F-value found is 3.739. Result: calculated FB is 3.46 and tabulated FB is 3.739. Here, calculated value is less than tabulated value. Hence, there is no significant difference. Thus, accept null hypothesis. Conclusion: there is no significant difference in averages of dissolution of all 3 tablet products. One-way versus two-way ANOVA. One-way ANOVA and two-way ANOVA can be differentiating in various ways. One-way ANOVA deals with only one categorical variable. Two-way ANOVA deals with 2 categorical variables. Synonym of one-way ANOVA is completely randomized design, while Two-way ANOVA is randomized block design. One-way ANOVA is extension of the unpaired t-test, while two-way ANOVA is extension of the paired t-test. There is only one null hypothesis and one alternative hypothesis in one-way ANOVA, while two-way ANOVA, there is two null hypotheses and two alternative hypotheses. Separate equations can also there in both types of ANOVA, like BSS and WSS, in one-way ANOVA, in RSS, CSS, in two-way ANOVA. One F value calculated in one-way ANOVA, while two F values for two variables calculated in two-way ANOVA. End of the topic of ANOVA. You can refer to these mentioned books for this topic. Fundamentals of Statistics by S.E. Gupta. Pharmaceutical Statistics, Practical and Clinical Applications by Sanford Bolton. Please take a note on important study questions. Thank you.